3, 2, 1.
I'm going to explain to you what's known as the central mystery of quantum mechanics. It was Richard Feynman, the American physicist, said, this is the central mystery of quantum mechanics. There's lots of weird stuff that goes on in the quantum world. Hit you with this, and it basically tells you what it's all about. It's called the two-slit experiment. I'll start with this. Imagine you have a source of light shining against a screen with two slits. Now, for the pedants in the audience, this source of light has to be monochromatic light of a particular wavelength. Well, whereas, of course, a light bulb is white light, and that's made up of all the colors of the spectrum, lots of different wavelengths. But imagine this is just a single wavelength of light, and you can see the light is coming out in waves like ripples in a pond. That's the nature of wave-like behavior. As the light hits the screen, it squeezes through the two slits, and each slit in turn on the other side becomes almost like a new source of light, and the light spreads out, it diffracts. And as the waves of light overlap, they will interfere with each other. So where a crest hits a trough, they will cancel. Where a crest hits a crest, they will amplify, and so on. And so on the back screen, you end up with what's called an interference pattern, a series of light and dark fringes, where the waves have either cancelled out or worked together in phase. That's fine. That's not quantum mechanics. That's a property of light that goes back over 200 years that we've known about since the early 19th century. Imagine doing the same experiment again, but doing it not with waves, but with particles. Do it with grains of sand. So this is the same experiment, but I've tipped it 90 degrees. Rather than waves that are spread out that wash up against the two slits and squeeze through, here you've got individual particles of sand, and each particle will either go through one slit or the other. And so you see they will sort of drain through, and you get two bumps underneath each of the slits. So the two peaks is reminiscent of particle-like behavior, whereas the multiple pattern of interference is wave-like behavior. What if we do the same experiment with atoms? Well, so imagine we have an atom gun, something can fire atoms, a stream of atoms. You can't see them because they're very small. Let's block off one of the two slits. So these two slits are the dimensions and separation of the slits is chosen appropriately to show us how atoms do things. And so far, so good. Nothing strange here. You'll see a lot of atoms hitting the back screen. So this will now have to be some sort of photosensitive screen whereby when an atom hits it, it'll give off a little flash of light to say the atom has arrived here. So the atoms are arriving as these little pinpricks of light that we see. Of course, a lot of the atoms will be blocked by the first screen. They won't go through that slit. But those that do get through to the other side, and you can see there's a bit of spreading of the atoms. But if we didn't know anything about atoms, we'd say, well, that's fine, we can understand that. A lot of the atoms are going clean through the slit. Some are sort of maybe bouncing off the edge of the slit, and so they're sort of being deflected a bit, which is why you get a bit of a spread. The first mystery of quantum mechanics comes when we open the second slit. Because now we see something that's very much like the interference pattern we got with light. Rather than having two bands of spots where the atoms have gone through the two slits, it's as though the atoms have gone through the slits behaving like waves, and you get interference of the waves, and you get these bands. If we know nothing about atoms or quantum mechanics, you could try and rationalize it and say, well, maybe atoms behave in a very strange way, and only a certain number of them are allowed to all sit together. And so, me and my gang, we're all going to go on this slit. No room for you. You go the next slit above. And by the way, there's this rule that no one can go in between the two bands, but a few naughty atoms do. So there's a bit of a scatter. We don't. There could be some forces between atoms that make them coordinate their actions in a way to give this pattern. That's not
forces between atoms that make them sort of work this order out to form a pattern, an interference pattern or a wave. I mean, we're just getting a little science-y over here on TDR. We're talking about, the elements. Ahab to the bro, natural by law, man. Make sure you are rocking with every step on his channel, every step on his IG, because the bro's breaking it all the way down in the naturalist on TDR Wednesdays, man, 10 o'clock Pacific, breaking down. I mean, is there really a speed of light? What is light speed? Do elements travel faster than the speed of light? We're talking light particles, we're talking atoms, we're talking patterns. This is science drop. Let's go.
Mysterious. We just don't know how atoms do things. But we can be clever and we can force the issue. What if we were to not send the atoms all through at once, but send them through one at a time? Leave enough of a gap for the atom to get through to hit the screen. Of course, as I say, some atoms will hit the first screen and not get through, but those that get through will hit the back screen. So let's run the experiment again slowly, and gradually you'll see as the atoms go through, they'll look like they're just randomly arriving on the other side. You keep sending atoms through one at a time, and gradually that same pattern appears. So each atom by itself is somehow contributing its small part to the overall wave-like behavior that we...
Are you contributing your small part to the overall wave? Each atom is contributing its own small part to the overall wave. So we all got a role in this pattern, in this particular design. Remember, it's all about observation, repeatable and observable science. This is science. Drop, dig on it. What is your contribution?
Small part to the overall wave-like behavior. Now contributing its small part to the overall wave-like behavior that we see in the interference pattern. How does it do it? How does... We know the atom's a tiny, localized particle. We can't say it's too small to even see under a microscope. We're firing it at the screen with the two slits. Some moment later, you see a flash of light on the back screen. It's arrived in a localized point. It's not spread itself out. You don't get sort of like a wash of a faint light across the whole screen. It's a little point. The atom is localized. It's arrived in a certain location. And yet, it somehow seems to have been aware of there being two slits, not one, because it's given rise to this interference pattern. How does one atom do that? Does it split in half? Does it become like a cloud that goes through both? Well, we can try and be even cleverer. What if we were to spy on the atom and see where it goes? We can gently just observe which slit it goes through. So you put a detector just above the upper slit that will flash or beep whenever it sees an atom go through that top slit.
Observation.
Sure enough, you fire the atoms through, one at a time. 50% of the time, the detector will beep. The other 50% of the time it doesn't, the assumption being that the atom has gone through the lower slit. But of course, I've been cheeky here. I haven't shown you the results of the experiment. That's what you get. 50% of the time, it beeps, and you see a spot arrive adjacent to the upper slit. The other half of the time, it doesn't beep, but you see a spot arrive at the lower slit. So, yeah, it's picked out the atoms that have gone through the upper slit and not the ones that have gone through. So each atom does go through one slit or the other. But that's a different result to what we had earlier. So here's the last bit of sneakiness that we can play with atoms. Surely now, we're going to get to grips with it. Leave the detector there, but just very quietly go and unplug it. Don't let the atoms know that you're not spying on them. Make them think that you're still detecting them. So, yeah, okay, we're going to run the experiment. Atoms, okay, get ready, one at a time. We're going to be checking on you. All right, so run the experiment again. Now, if you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you. Quantum entanglement is the idea that particles, however far apart they are, still somehow...
One more again.
All right, so run the experiment again.
Bang. It's not the... it's not just the simple fact of, here's a camera. I mean, because clearly they're playing with these atoms, man. Like, they're conscious, right? They're over the fact that this is beyond their, understanding, right? But they're now playing with these individual atoms. I need you to wrap your noodle around this. This is science drop. They're not even trying to really explain this at this point. They're just playing with conscious energy, frequency, vibration. Now, what are you made of? They say a bunch of atoms, right? A bunch of these particles make up you. So there's a consciousness to you that is beyond what's in your brain. It's beyond what you've learned. Not just you, everything around you. Think about all the particles, the energy, the electrons, the neutrons, the protons, subatomic particles, as small as you can get, whatever you want to get, nanoparticles, nanotech, conscious. I mean, think about, when they have the nanotech, saying that they can, use nanotech to, there's TV shows, like Black Mirror and all kind of little shows, where they're using this nanotech, to heal whatever's in your body, whatever's wrong with you. Man, what's that show? Man, I was just watching it, man. A little replay of it. Man, what's that thing called? It's going to come to me later. You know what I'm talking about, though. Know what I'm talking about. Man. But yeah, it's like all these sciencey joints, And then suddenly these nanoparticles are able to find whatever, the cure is that you need this, or the cure for that. And, they could just, inject you with these nanoparticles and X, Y, and Z. Or what? You have consciousness. They're injecting you with consciousness. Because every single atom knows when it's being observed. One more time.
But of course, I've been cheeky here. I haven't shown you the results of the experiment. That's what you get.
That's what you get when this light is on, right? You got the red light special. Observing, because first they just like, which slit out of these two? And this is a very popular experiment. We're going to get a couple different looks at this particular experiment, from different scientists trying to break this down. Repeatable and observable science, man. So they're observing, they're actually showing the science of observing these particles and how they're consciously, you can't make this shit up. They're forming a whole nother pattern, rather than having this full interference pattern. Where did we get it before? All right.
Actually,
Bang. When it's not being observed, it's forming and hitting all possibilities. It has a wave pattern that will continue way beyond this, metal sheet or whatever they're using. There will be a pattern, and they're like, whoa, which slit is this one particle going through? And they're going particle by particle by particle. First, they're just shooting out random, rapid fire, and then they slow it down, and they're still getting the same, pattern, the same wave. Is performing like light, right? But can elements move faster than the speed of light? Well, it's just a wave. It's just a wave, man. You're just surfing the wave. Every single particle knows where it has to be. Now, it's all possibilities, right, when it's not being observed. But when you observe it, something happens to where he just got to start turning into a comedian, right? He just turned into a comedian now because there's not really much he can really say. He just has to say, well, is there any reason that you can give me why this should be happening?
Has gone through the lower slit. But of course, I've been cheeky here. I haven't shown you the results of the experiment.
Because when this camera's on, it's no longer choosing all possibilities. It's choosing a specific possibility. And then, he did the, final bit of trickery, right? They kept the camera up, but they just turned it off. They said, well, maybe this conscious energy sees the camera and is doing what hitting the possibility that we think it should hit. Just playing with us. Maybe it's just playing with us because that's what they're getting is that these particles are alive, they're conscious, and they're fucking with us, right? But then it's all right, I got you, conscious particles. I'll keep the camera up, but I'm just gonna turn it off. And it knew it was no longer being observed. It went right back to
You
this.
can explain this using common sense and logic.
If you can explain it, do so. That's all we are. Since they can't explain it, Drop Nation, I figure, we can at least, dig on it with a dragonfly perspective. Because if you remember this video right here, this little quick 4 or 5 minute joint, this really popped it off for us, man. We were digging on this, I think in 2016 or something like that. So, I just want to revisit it with a dragonfly perspective because we just talking about science, Drop, man. Quantum mechanics.
Here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment.
This is the granddaddy of the mystery behind quantum physics or quantum weirdness, because they have to only accept really the result is that they don't know. The only result that they can be forced to accept is that there seems to be consciousness dealing with even individual particles. So the main question is, if observing these particles turns it into a fixed pattern, the two slits instead of the full wave, what happens when you don't observe it? In real time, when you go to sleep at night and you're not observing the world, how do you know that any of this shit is going down at all? You're not observing it. It's not like it's not going down because it's really hitting all possibilities. So yeah, the possibility that okay, I'm married, I got 2 kids, I live in this house, I have this job. That's the only possibility you got, right? Because that's the life you're observing, right? The Most High says, that we are, we will be witnesses, right, to the glory of Ahchwa, right? You are the witness. We are witnesses, right? When we are surfing the wave, we have witnesses to, the pedigree, the drive, the determination, the results. We have witnesses to this. But I'm just saying, the power of witnessing is off the hook, man. And we're revisiting a lot of our golden nuggets and golden spikes along the way, along the road, because I want you to know how important the recon you've been doing, man, over these last few years has been, you know what I mean? And, it's important to reflect on the journey that we've all taken, you know what I'm saying? And this particular flow, this wave that we're in, we get science drop, we get health drop, right? We get, drop artists and drop producers, we get our flat drop and orientation. Obviously, man, we're always grounded in digging in Torah, Tanakh. We're looking in between the timelines. We're digging on chronology, man. All right, we're digging on the indigenous truth all day. Of course, we got the Presta series. We're digging on Drag and Drop. All this is popping, in an original, fluid wave that we're in, man. And all praise Ahchwa, because it brings us right back to witnessing. What are you witnessing? See, someone could witness, our flow and say, oh, well, this is the only possibility I see. And then someone else could witness it and say, yo, man, all praise the creator. It's unlocked so many things for me. And that's what you witness. The power of witnessing, when we say choose up, we're saying, what are you going to witness about yourself, man? About your thoughts. How are you going to witness your thoughts? Again, you're just talking about, being framed and shaped into a particular probability, a particular result. You say you want freedom, right? You say you want revolution, you want change. Well, what are you going to witness to get to that fixed possibility? But just know that without you witnessing anything, it's all happening. It's all happening. It's all happening. All probabilities, all possibilities on every level, on every part of the octave. You got your life popping off here. You got a life popping off on this octave, on that octave, on this level, on this level. How many lives do you have going simultaneously? You know what I'm saying? But because you're locked into witnessing one reality at a time consciously, you just think that this is the only life that you're living. But you close your eyes, you're back in the ether. It's all happening. All possibilities, all probabilities are in play. And you see these atoms, they just on that play, man. They like, oh, the camera's off. Let go, man. It's all happening. Oh, they watching? All right. This particular possibility, this particular probability. How does this, speak to how to really affect change, man? Love the Jay Stu. He's been digging on that change and just the evolving process, man. And how much of this has to do with that? We're just talking science drop. For you to witness change, I mean, the power of being a witness, man. Does it empower you to know that by witnessing, you can form a particular probability? You want that instead of that? Well, witness. What does it take to get there? What does it take to do that? You want to be physically, in shape, but what does it take to witness that? You have to put in that work, right? You have to witness that. Those that are witnessing you putting in that work will say, yeah, I know a result is happening. I've witnessed you put in that work. But without anybody witnessing, it's all happening, man. And remember, this is the one that popped it off.
To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So
it's all happening.
When we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles.
So what's the matter? The matter is the wave. Again, peace to the bro natural by law, digging on this dark matter. Are we free from the dark? I get the drop. The matter is the wave. I mean, when you talk dark matter, when you talk melanin, you know what I'm saying? You know, hey man, it's the wave. It's the wave. It's all possibilities. It's everything. This is the drop. This is the secret, man, to the all powerful probabilities of you. You know what I'm saying? When you tap into you tap into the entire wave. When you tap into your matter, you tap it into the entire wave. What's the matter? The matter's the wave.
How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself.
Wave of potentials. All happening.
Goes through both slits and interferes with itself.
One single particle goes through both slits. This is how they're trying to explain is because it's damn near unexplainable, which is why they're calling this the biggest mystery, which is why we had to get the double on the double slit experiment, man. One more again.
Comes through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials.
One single electron becomes a wave of potentials. All probabilities are open. One electron. But what's an electron? What are you? Energy, frequency, and vibration. What's your ancient love song? Energy, frequency, vibration. We're talking about the wave of potentials. Now you see how they've been playing with your wave of potentials, inserting, hijack into, creating one possibility through observation, through them observing you. You're now observing yourself through their lens, which is only giving you one probability. Right now it's death. Right now it's our failure. Right now it's captivity. Because you were looking at it through the lens of the invader. Through the invader's lens is what we're observing through until you break free of that, dodge the hijack, and oh boy, it's all happening.
Goes through both slits and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one.
It goes through both slits. It goes through neither. It's everything and nothing. What does that remind you of? The number 9, the law of 9. It's everything and it's nothing.
And it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of 2 bands, not an interference pattern of many. The very act of measuring or observing which...
Now think about this now. When they weren't observing, his explanation is that this particle turned into 2 particles, went through both of the slits, interfered with itself to form a full wave of possibility. Right? That's what he just said. This wave, this particle split in 2, right? Let me make sure I got it right. One by one, they shot it out.
They decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself
Bang.
to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither.
Mathematically, again, back to the law of the number 9. So we're back in our 9 flow. We're back in our spiral flow, all possibilities. Now when it's being observed, suddenly it's just performing just like a regular marble, right? But you're shooting the same electrons through the same slit. Why isn't it now not breaking into 2, going through both slits and interfering with itself to form this wave of all possibilities? What does the act of observation or witnessing do to crush all possibilities into one possibility? I mean, that's going to bake your noodle, you know what I mean? Because it's been baking their noodle for a long time. But we got this, we got this energy, though, We got a hot strudel coming out the oven. You know what I'm saying? They baking their noodles, man. We baking strudels, man. And dropping them. So suddenly, because it's being observed, it's not surfing the wave. You know what I'm saying? It's not all possibilities. It's saying, okay. And it's almost like that observation it's just like reflecting off of who's observing it, in a sense. You know what I mean? The real question is, does it change, when you observe it versus when the hijack observes it? You know what I mean? It's like, these particles are so conscious, right? Because we're talking about the wave. What if you observed it versus them? I mean, they haven't done this experiment, with the real ones observing it. Maybe it still be all possibilities, but when the hijack observe it, you're only seeing through the mind of a hijack, which only gives you one possibility, which again, right now, the world we know is being, pushed through that particular lens, that hijack lens, and giving us one particular possibility, being the tail instead of the head. Now, what are you going to witness? What are you witnessing? What happens when you observe you? Man, I mean, I'm just surfing the wave.
And it goes through just one, and it goes through just the other. All of these possibilities are in superposition
It's all happening
with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched.
And that's for real, for real. When they give us that one eye, single eye, on the back of the dollar bill, doesn't this kind of bring that into a higher octave, man, to really see the power of observation and whose lens, whose eyeball we're seeing through? From the moment we're born in this particular matrix, we're looking through the lens of the matrix. We're learning in their schools and these images on TV. We're learning this behavior, these emotions and this paradigm. And most of us don't have, parents that are, at the, seeing clearly enough to really, help us dodge these hijacks. So we just got to just take it on the chin, man. Bang, bang, bang. Until, one day we can climb, we can rise. But this eyeball right here, this possibility, this all-seeing eye, I mean, we're only getting one possibility. And of course, it's your death. It's your destruction.
And it was here that physicists stepped forever into the strange, never-world of quantum events. What is matter? Marbles or waves? And
What is matter, marbles or waves? We just said matter is all possibilities, man.
waves of what? And
All
what
possibilities.
does an observer have to do with any of this?
Yeah.
The observer.
What does the observer have to do with any of this? What does the observer have to do with any of this? Who's observing? Whose lens is it anyway? All right, man. We're just, brushing a couple of golden spikes here, man. Let's get. Oh man, I got one more here. Let's get one more of these. This one is the quantum experiment that broke reality. All right. We're just talking about breaking reality. We're just talking about getting out the matrix. Let's go. Hijack City, man. Hijack. Let's go.
This episode is supported by the Great Courses Plus. One of the strangest experimental results ever observed has got to be that of the single particle double slit experiment. It's one of the most stunning illustrations of how the quantum world is very, very different from the large-scale world of our physical intuition. In fact, it hints that the fundamental nature of reality may not be physical at all, at least in any sense that we're familiar with. Let's start with the familiar. In fact, let's start with a rubber ducky. It bobs up and down in a pool, causing periodic ripples to spread out. Some distance away, those waves encounter a barrier with two gaps cut in it. Most of the wave is blocked, but ripples pass through the gaps. When the new ripples start to overlap each other, they produce this really cool pattern. It's called an interference pattern. It's due to the fact that in some places, the peak of the ripple from one gap stacks on top of the peak from the other gap, making a more extreme peak. You also get more extreme dips when two troughs overlap. We call this constructive interference. But when the peak from one wave encounters the trough from another, they cancel out, leaving nothing. Destructive interference. So we have these alternating tracks of wavy and flat water. Any type of wave should make an interference pattern like this. For example, water waves and sound waves, but also light waves. This double slit interference of light was first observed by Thomas Young back in 1801. A source of light passing through two very thin slits produces bands of light and dark stripes, alternating regions of constructive and destructive interference on a screen. Of course, we now know that light is a wave in the electromagnetic field, thanks to the work of James Clerk Maxwell a century later. So it makes perfect sense that it should produce an interference pattern, right? But wait, we also know that light comes in indivisible little bundles of electromagnetic energy called photons. Einstein demonstrated this through the photoelectric effect, but his clue came from the quantized energy levels of Max Planck's blackbody radiation law. Check out our episode on this for the details. Okay, so each photon is a little bundle of waves of electromagnetic field, and each bundle can't be broken into smaller parts. That means that each photon should have to decide whether it's going to go through one slit or the other. It can't split in half and then recombine on the other side.
But that's what the other, cat, Dr. Quantum was saying. It must split apart, go through both slits and come back together, form this interference pattern. Now, right quick, when they keep saying interference pattern, let's take a step out of the English language and just use our own observation. Is it an interference pattern? Or are you just talking about, the cross sticks? You know what I'm saying? Just a connection. In this connection, it's just many connections. You know what I'm saying? Many crosses, many crossroads, many tiles, right? To get to a particular design that appears to be infinite possibilities, infinite cross sticks, infinite crossings, what they're calling interference. Constructive interference or destructive, right? Constructive. Let's go.
That shouldn't be a problem, as long as you have at least two photons. One photon passes through each slit, and then the two photons interact with each other on the other side and produce our interference pattern. But here, we get to one of the craziest experimental results in all of physics.
Everybody's saying this is the craziest shit, so, we gotta dig on it. Let's go.
Interference pattern is seen even if you fire those photons one at a time. Well, let me back up a bit. The first photon is detected as having arrived at a very particular location on the screen. The second, third, and fourth photons also. They deliver their energy at a single spot, and so they appear to be acting like particles of well-determined position. But check it out. If you keep firing those single photons, you start to see our interference pattern emerge once again. By the way, Veritasium actually conducts this experiment in his excellent series on the double slit experiment. Really worth a look. This is so bizarre. This pattern has nothing to do with how each photon's energy gets spread out, as was the case with the water wave. Each photon dumps all of its energy at a single point. No, the pattern emerges in the distribution of final positions of many completely unrelated photons. How can that be? Each photon has no idea where previous photons landed or where future photons will land. Yet each photon reaches the screen knowing which regions are the most likely landing spots and which are the least likely.
Well, you know what I mean? They before said that with observation, these photons know they're being observed. So why wouldn't they know where the homies are? Why wouldn't they know how to tribe up? If they're conscious of being watched, they don't know where the homie is. They don't know the grand design. They don't know how to play their position, play their role, and how important this is more than just each little dot. See, we come together, we tribe up, not for each little dot, but to form the wave, man. The full pattern, the full design is the most important part, and the entirety is Ahchwa.
It knows the interference pattern of a pure wave that passed through both slits equally, and it chooses its landing point based on that. It turns out that the photon isn't the only thing that does this. Shoot a single electron through a pair of slits, and it'll also appear to land at a single spot on the screen. But fire many electrons, and they slowly build up the same sort of interference pattern. This crazy effect has even been observed with whole atoms, even whole molecules. Buckminster Fuller.
Even whole atoms, whole molecules, no matter what we're talking about, matter. What's the matter? Matter is what? We're just a bunch of protons, electrons, atoms, and this and this. All of this is consciousness. Do you see clearly? All of it is conscious. Look at your hands. The consciousness. The table you're at. Consciousness. The house you're in. The tree, right? Everything around you. Everything that, science says is formed of all these atoms. This is what they're firing, and this is what is reacting to being observed and proving that it knows when it's being watched, man. Do you know when you're being watched? Can't you feel when you're being watched? Consciousness.
Fluorine. Buckyballs are gigantic spherical molecules of 60 carbon atoms and have been observed to produce double slit interference under special conditions.
60 carbon atoms. One more time.
Spherical molecules of 60 carbon atoms.
This is the Buckminster Fullerene buckyballs, all right? 60 carbon atoms. So again, what's melanin? What's carbon? All right, two different words for the same thing. What makes up a carbon? I mean, you know what I'm saying? The 666, the mark of the beast and all this revelation stuff. 6 carbons, 6 protons, 6 electrons. I mean, look, man. I bet it's all happening. All right? I get too excited because of all the possibilities. When you talk about carbon, when you talk carbon 12, that's all you're talking about. You know what I mean? 6 protons, 6 neutrons, 6 electrons. You know what I'm talking about. So all of this is alive, man. All of this is consciousness. It's not just what you are perceiving through what you consider your brain. It's the wave, man. How do you bend the spoon? You are the spoon.
And have been observed to produce double slit interference under special conditions. We have to conclude that each individual photon, electron, or buckyball travels through both slits as some sort of wave. That wave then interacts with itself to produce an interference pattern. Except that here the peaks of that pattern are regions where there's more chance that the particle will find itself. It looks like a wave of possible undefined positions that at some point, for some reason, resolves itself into a single certain position. We also saw this waviness in position when we talked about quantum tunneling. In fact, several quantum properties like momentum, energy, and spin all display similar waviness in different situations. We call the mathematical description of this wave-like distribution of properties a wave function. Describing the behavior of the wave function is the heart of quantum mechanics. But what does the wave function represent? What are these waves of, or waves in? Let's start with what we do know about the double slit result. We know where the particle is at both ends. It starts its journey wherever we put the laser, or electron gun, or buckyball trebuchet, and it releases its energy at a well-defined spot on the screen. So the particle seems to be more particle-like at either end, but wave-like in between. That wave holds the information about all the possible final positions of the particle, but also about its possible positions at every stage in the journey. In fact, the wave must map out all possible paths that the particle could take.
All possibilities. Starts out as a particle, finishes as a particle, a wave in between. Okay. So you start out as a particle, finish as a particle, and everything in between is just a wave. You know how they say you got to start strong and, finish strong, and everything that happens in between, man, is as long as you kept the feet moving, kept the water flowing, kept the fire burning, man, you finished strong, you finished the race. You were able to, truly ride the wave to victory, man. Or, you could look at the wave as the water like they were doing, and you're just talking to Mem, and just like the script say, we always bring it back to the script. You know what I mean? Just that, when you talk about Mem and the water, wisdom of Solomon, you know what I'm saying? You got Mama literally saying that she come at you crooked, man, to make sure that you in line with the law before she really, bestows the gifts. You know what I'm saying? The water, the wave, all possibilities. What really makes them clear so that you can see clearly, you got to be in order. Because that wave could wash you up. It can lead you or drop you off at a whole nother possibility, right? But in reality, all possibilities are in play as long as you choose up. But when you're in order, you're surfing the wave, you're not going against it. In order, you can, truly see and experience all possibilities. I mean, beyond, I put it like this, I'm saying? You come into the womb, you're a baby, bang, consider that a particle. And then, you grow, old, and, you're 150 years old now. And, everything that happened in between is just a wave, and everything that's going to happen after you so-called, pass away, you're back in the wave of all possibilities. Now, depending on how you observed. Now, who's the ultimate observer? That's really the beautiful thing is when you look at the all-seeing eye, example again. Yeah, we are looking through the eye of a hijack, but what's the ultimate observer? That's the creator. That's what we call the everything, the ancient head of days. You know what I'm saying? The all-knowing, the all-seeing, the true all-seeing, right? Now, when you are in line with the wave, you are now in line, with those particular possibilities that your creator wants for you. See, even though there's all possibilities, not all these possibilities are, so-called good possibilities. I mean, depending on your perspective, right, of the possibility. It could be a bad situation that you can get good out, you can get some dropout, you can learn from, you can grow, you could be framed and shaped through, spiraled up by. But that's the wave of all possibilities, man. The more you choose up, man, the more you reach that particular, possibility or that mark that you want to hit. It's there for you. Whatever you want to do, whatever you want to become is there for you. It's right there for you. There's nothing in between you and it. You just think there's something in between you and it. But it's right there. And there's also the possibility of all the so-called negative things, right? So you don't really want to hit every single possibility per se. Not if you have your mind made up, if you got your heart, what design, you want to, witness or observe, then you can, choose up and surf that wave to hit that particular mark, knowing that you're part of the grand design. But you can't go against the water, the wave.
We have this family of could-be trajectories from start
Because the wave has you surrounded, man. It's all happening.
to finish. And for some reason, when the wave reaches the screen, it chooses a final location. And that implies choosing from these possible paths. So what causes this transition between a wave of many possibilities and a well-defined thing at a particular spot? Within that mysterious span between the creation and the detection, is the particle anything more than a space of possibility? Okay, we're adding more questions than we're answering. We still didn't figure out what the wave is made of. In fact, the answers aren't known, but the various interpretations of quantum mechanics do try. Let's
All right, translation, we don't know shit about this. We don't know shit about this, man.
We're adding more questions than we're answering.
No, it's okay. Let's go.
Could be trajectories from start to finish.
Because we don't need the answers. We just need to have the right questions. Because it's all possibilities.
And for some reason, when the wave reaches the screen, it chooses a final location. And that implies choosing from these possible paths. So what causes this transition between a wave of many possibilities and a well-defined thing at a particular spot? Within that mysterious span between the creation and the detection, is the particle anything more than a space of possibility?
Translate it, man. Get the dropout. So between that space of creation, right? Again, how do you pay attention to the wording? Pay close attention to the wording.
So what causes this transition between a wave of many possibilities and a well-defined thing at a particular spot? Within that mysterious span between the creation and the detection.
Between the creation and the detection. So you're detected when you come out the womb, right? And they got the detectives on you. They probing you. They trying to take your blood, right? They want to shoot you up with all kinds of, poison. They just want to put the detection all upon you between creation and detection. There's a wave of all possibility. Now, once that baby come out, once you come out, now they were giving you one possibility. Here's the earth you live on. We're going to talk about some orientation for the dismount because I want to go, I wasn't sure how these things would connect, but, we're just talking about observation here, man. And, when you talk about, the earth and, the curvature and all this stuff, it's like, or the orientation, east, west, whatever, they give you that. They're now giving you one possibility. Here's the map. Here's the land on the map. Here's the ball. The sun is 96 million. They give you all these particular things, about gravity. But then you say, oh, it's a theory, not a law. So there's still all possibilities in play if gravity's just a theory, not a law of what? There's no repeatable and observable signs of gravity, not when you change the model and put it into a density format. Now, you understand that the cup is going to hit the ground because it's denser than the atmosphere, not because there's any force pulling it down, but because of density. Now, this is just physics, people. We're talking quantum physics. So now you can see a correlation between this quantum physics and the physics, and this scientific, jargon that's getting pushed onto us, and how this can, literally be shifted by switching models up. It's all happening, man. You don't have to take their model of one particular possibility because they don't want you to ask any more questions because they think they have all the answers, right? And if you ask a question and they say, oh, you know more than the science, you know more than the scientists, it's all happening. That's why I have a question, because all possibilities are in play.
Is the particle anything more than a space of possibility?
All happening, man. You're just limitless possibility. Everything about you, all of your energy, frequency, vibration is limitless possibilities.
Okay, we're adding more questions than we're answering. We still didn't figure out what the wave is made of.
Let go.
In fact, the answers aren't known, but the various interpretations of quantum mechanics do try. Let's talk about the view favored by Werner Heisenberg and Niels Bohr, who pioneered quantum mechanics at the University of Copenhagen in the 1920s. The Copenhagen interpretation says that the wave function doesn't have a physical nature. Instead, it's comprised of pure possibility. It suggests that a particle traversing the double slit experiment exists.
I just want to kind of read this without him for a second. The Copenhagen interpretation. Let's just get a piece of this. The Copenhagen interpretation is an expression of the meaning of quantum mechanics that was largely devised in the years 1925-1927 by Niels Bohr and Werner Heisenberg. It remains one of the most commonly taught interpretations of quantum mechanics. According to Copenhagen interpretation, physical stems generally do not have definite properties prior to being measured. Again, physical systems, physical systems generally do not have definite properties prior to being measured. So you can't govern the physical with anything definite. What's matter? It's the whole wave. What are you? The entire wave. What do we keep saying? Surf the wave. Take the surf the wave challenge. Just dig on it. Empty your cup, because it's all possibilities. Why is your cup so full? Why is your cup so full? Physical systems generally do not have definite properties prior to being measured, and quantum mechanics can only predict the probabilities that measurements will produce certain results. All they can do in their science, when they say that we have answers, all they can do, even on the quantum level, only is predict the probabilities that measurements will produce certain results. They can only say there's going to be certain probabilities, but they can't say it's all happening. They can't say that you're surfing a wave of endless, limitless, probabilities, possibilities, results. All results are truly in play. So when we say that we can do something, don't tell us we can't. When we say we're investigating something to look into these possibilities, just like I was kicking with the Prester John, when you got folks on the sidelines, snaring as we, dodging a hijack in between the timelines. What are you snaring for? How can you say, oh, well, Prester John must be, this particular figure or that, or he must be. We're talking priest kings, man. We're talking the priesthood. We're talking all possibilities when we talk energy, frequency, vibration, and the vortexes. Who's guarding them? It's all happening. So when you dig on these investigations, we dig on the investigations because we are investigating. And you can never knock an investigation as if you have the one probability, the one possibility. You got the answer because of your recon. Well, put your recon out. Let's dig on your one possibility. We're saying it's all happening. It's a wave function. You're collapsing the wave function. You're being real sciencey, right? You're collapsing the wave function of our investigation, not allowing us to dig on all the results. The act of measurement affects the system, causing the set of probabilities to reduce to only one. I got the answer. Prester John must be a hijack. I got the answer. Prester John must be, this. Man, you're reducing an investigation to one possible value. But we see the value of the entire wave. We see the value of all the probabilities, not just to reduce to only one of the possible values immediately after the measurement. You're coming up with this after we already are engaging in these measurements in the recon. Now you can say, oh, here's my one possibility after what? Immediately after the measurement. You wait for us to have the measuring stick, and then you say, well, here's my result. Nah, man, it's all happening. We're talking about the complete set of probabilities, not just one possible value immediately after the measurement. This feature is known as wave function collapse. There has been many objections to the Copenhagen interpretation over the years. Some have objected to the discontinuous jumps when there is an observation, the probabilistic element introduced upon observation, the subjectiveness of requiring an observer, the difficulty of defining a measuring device, or to the necessity of invoking classical physics to describe the laboratory in which the results are measured. They don't know. They can't explain these discontinuous jumps. They can't explain why, one, result will hit this particular point and 1 point here and 1 point here. But after an hour, it's a pattern, the same pattern when it's not being observed. So we don't need all observers. We don't need the type of observers, especially when we're surfing a wave. I'm just making this relatable. We don't need the type of, observers that's going to collapse our wave. See, that's true interference. That's true static. We need the type of observers, that are observing, or at least are open to the observation of all probabilities, man. That's how you surf the wave. Let's go.
Only as a wave of possible locations that ultimately encompasses all possible paths. It's only when the particle is detected that a location and the path it took to get there are decided. The Copenhagen interpretation calls this transition from a possibility space to a defined set of properties the collapse of the wave function. It tells us that prior to the collapse, it's meaningless to try to define a particle's properties. It's almost like the universe is allowing all possibilities.
Again, it's meaningless to try to define the particle's properties. It's meaningless to say, I got the answer of your particular flow, of your particular, investigation, whatever you are looking into. When we look outside of ourselves, we're only looking inside of ourselves. When we're searching, we're mainly searching for ourselves because you are all possibilities.
Transition from a possibility space to a defined set of properties, the collapse of the wave function.
Don't collapse our wave. Don't collapse your wave.
It tells us that prior to the collapse, it's meaningless to try to define a particle's properties.
Before you see one possibility, it's meaningless to try to define all of the properties. It's meaningless. You have to first wait and see what we're doing, right? Or they have to wait and see what we're doing. Then they can say, oh, let me try to define it. Let me try to define their flow. It's meaningless prior to the collapse. After they've collapsed our probabilities, now we're seeing it through their eyeball, their lens. Now they can try to define and put this definition on who we are. But if they can't tell us who where we're from, how can they tell us who we are? They can't tell us who we're not. How can they tell us who we are? It's meaningless to try to define. Again, it's meaningless to try to define all possibilities prior to the collapse of the wave.
This transition from a possibility space to a defined set of properties, the collapse of the wave function. It tells us that prior to the collapse, it's meaningless to try to define a particle's properties.
Bang.
It's almost like the universe is allowing all possibilities to exist simultaneously, but holds off choosing which actually happened until the last instant.
Ahchwa is allowing all possibilities. You have to choose up.
Weirder. Those different possible paths, those different possible realities interact with each other. That interaction increases the chance that some paths become real and decreases the chance of others. There's an interaction between possible realities that is seen in the distribution of final positions, in the interference pattern. That pattern is real, even though the vast majority of paths involved in producing the interference never attain reality. In the Copenhagen interpretation...
So what's reality? Before we talk about Platonic solids, love to the Templar, what's reality? There's many realities, man. Which one are you choosing? Let's go.
That final choice of the experiment of the universe is fundamentally random within the constraints of the final wave function. The theory of quantum mechanics produces stunningly accurate predictions of reality, and it's completely consistent with the Copenhagen interpretation. But this is not the only interpretation that works. There are interpretations that give the wave function a physical reality. Remember, we know that light is a wave in the electromagnetic field, and quantum field theory tells us that all fundamental particles are waves in their own fields. This may give us a more physical medium that drives these waves of possibility. And if you thought the Copenhagen interpretation was freaky, wait till we get to the many worlds interpretation.
Oh boy, we about to go there, but man, again, AI up to my jigger, man, because he's been breaking down this ether every Sunday, man, 6 o'clock Pacific. Get in the classroom with my jigger, only on TDR at 432thedrop.com. Get the app. Sunday, 6 o'clock, Ma come in, man. My jigger come in with that ether drop. I mean, man, naturals flowing with it. I mean, love to Yosef the Real, man, coming in at 7 o'clock on Sunday. This is just how we are waving up. And why are we connecting it? Because it's just a wave. Particle, 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 hitting the mark, hitting the mark, hitting the mark. What's the ether then, man? Because they're trying to measure the earth flying through the ether. But they find that there is no interference, right? I mean, not with no movement of the earth flowing through space. There's no, it would be cutting through the ether, but what did Einstein do? He abolished the ether. He threw it out the equation. So when you think about this wave, when you think about light, put it all in the context of the ether. That's why we say we in the ether with it. Oh, man, my little homie's in the ether. Let's go, man. The many worlds interpretation.
Which we will, right here on Spacetime. Thanks to the Great Courses Plus for sponsoring this episode. The Great Courses Plus is a service that allows you to learn about
All right, man. We're just talking physics, right? And I'll leave this for you, man. This is from plus.maths.org. Physics in a Minute, the double slit experiment. One of the most famous experiments in physics is the double slit experiment. It demonstrates with unparalleled strangeness that little particles of matter have something of a wave about them. Surf the wave. and suggests that the very act of observing a particle has a dramatic effect on its behavior. So when you're not observing, it's dramatically different. There's all possibilities. To start off, imagine a wall of two slits. All right, man. So, just reiterating some of the drop, but this is something that you can actually read through and share. Do it without the YouTube, without the videos. You know what I mean? You could just kind of dissect it. Just getting, going back into this interference pattern. And these are real images from Dr. Tanamura and Belshazzar. All right. They say, here's an image of a real double slit experiment with electrons. The individual pictures show the pattern you get on the second wall. As more and more electrons are fired, the result is a stripy interference pattern. How can this be? One possibility might be that the electrons somehow interfere with each other so that they don't arrive in the same place they would if they were alone. However, the interference pattern remains even when you fire the electrons one by one, which is what we were digging on. So what does the experiment tell us? It suggests that what we call particles, such as electrons, somehow combine characteristics of particles and characteristics of waves. So when they say you're made up of these particles, what they're trying to say is that you are the wave. But that gives you infinite possibilities. But then the creators say that ye are gods. You know what I mean? Hey, so which one is it? Are you the wave? Or if you're the particle, if you're the atoms, surely you are the wave. But who's observing who? That's the famous wave-particle duality of quantum mechanics. It also suggests that the act of observing, of measuring a quantum system has a profound effect on the system. We're talking the matrix. The question of exactly how that happens constitutes the measurement problem of quantum mechanics. Oh, man. So, dig on it more. I told you, man, this is all about observation. It's all about observation. And just quickly for the dismount, man, hey, hop to the real ones. I'm in this, I'm on part, or number 62 out of 200 proofs. The Earth is not a spinning ball by Eric Dubé. And I'm going to get some more drop on it. But, number 62, it says Samuel Rowbotham's experiment. Let's get a little bigger. The old Bedford level proved conclusively the canal's water to be completely flat over a 6-mile stretch. So, we're shifting gears, but we're really, this is just all possibilities, man. We're still talking about the water. All right, we're just talking about the water. Let's go. So in this experiment, they measured a stretch of 6 miles in this canal. And just by default, if you're on a ball, that means either 1 mile, every mile should be at least 6 inches, I believe, of curvature, 6 to 8 inches. 6 inches or 8 inches, but I think it's 6. Either way, you're on a ball. The water should be curving. The water should not be flat forever. That's not the model, right? The water must be in a ball, right? It must be in a ball with gravity keeping it as it spins at 1,100 miles per hour on a wobble going over 67,000 miles per hour. Right? All this movement, all this water, nothing spilling out in the vacuum of space, the vacuum. Water in a vacuum. So none of these experiments are observable and repeatable when it comes to the lie of what they're telling us. You've never seen water curve in a ball. You've never seen how gravity affects water or curving water. And no, a zero gravity experiment doesn't count because it's a zero gravity experiment and your model has gravity. Capiche? Your model does have gravity. Gravity is the god of science. It is the reason why everything is sticking to the ball and perfectly balanced, right? So you can't take gravity out and say, oh, but what about a bubble? In zero gravity, water turns into a ball bubble in zero gravity. Hey, man, you got gravity, man. All right, let's go. First he stood, so they're on the 6 mile. They're trying to find any curvature in the water over this 6 mile stretch. Again, every mile should be at least 6 inches of curvature. So in 6 miles, you do the math, it should be 36 inches of measurable curvature between one end of this canal and the other. So again, when you talk about going on a cruise or, on a boat from California to Hawaii, there should be measurable, I think at least, over, I think a number of miles by that time, miles of curvature. Now you're talking about miles of curvature. Over this 6-mile stretch, you're just talking about, about 36 inches, right? About a foot, about 3 feet. Should be at least 3 feet. First, he stood in the canal with his telescope held 8 inches above the surface of the water. Then his friend in a boat with a 5-foot tall flag sailed the 6 miles away. If Earth were a ball, 25,000 miles in circumference, the 6-mile stretch of water should have comprised an arc exactly 6 feet high in the middle. So the entire boat and flag should have ultimately disappeared. So we just said 3 feet. But again, they doing the math. I guess at the height of what they call it, the height of the arc, should be 6 feet. All right. I mean, I'll defer to their math. Either way, whether it's 3 feet or 6 feet, there should definitely be some curvature, measurable curvature in that 6 miles. You don't have 6 miles of flat water on a ball. Just stop it. Just like with the bridges, you don't build a bridge, 100 miles across without accounting for the curvature that there should be measurable, at least 6 inches per every mile. You do a 100-mile bridge, that's 600 inches. And you do the feet and you do all that of curvature that should be accounted for. That bridge should be curving. All right? It shouldn't be a straight bridge. And what engineer is going to come out and say that they've accounted for curvature when they build these bridges? You think when the Aztecs built the railroads, they said the Aztec built the railroad, the Chinese, whoever they want to claim, you think they accounted? You think these indigenous people that built these railroads accounted for curvature? This railroad's going from LA to New York, 3,000 miles. You know how much curvature should be accounted for in those railroad, tracks? You think they were laying the tracks down, saying, okay, let's start curving these tracks a little bit, at least 6 to 8 inches every mile to make sure we are, fitting this round ball. Nah, they just go straight. No one's accounting for curvature in building railroads thousands of miles. All right, no one's accounting for curvature in building bridges hundreds of miles, and no one's accounting for curvature when they sail, all across the globe, right? Because of all this curvature. But in their minds, they're saying, yeah, the water's curving. I'm circumnavigating the globe. I'm going over the curve. The boat's disappearing past the curve, and then they zoom in on a high-powered telescope, and the boat is still there because the water does nothing but flatten out. Water never curves. Water never curves. Show me an experiment with water curving. Water's always level. Water's always flat. Again, it's called sea level, not sea curve. Sea level. If Earth were a ball 25,000 miles in circumference, the 6-mile stretch of water should have comprised an arc exactly 6 feet high in the middle, so the entire boat and flag should have ultimately disappeared. Because you remember, they had a 5-foot tall flag on purpose because they knew that this 6 feet high, arc in the middle would be enough to make this flag disappear. But did it? When in fact the entire boat and flag remained visible at the same height for the entire journey. Body bag, Daniel. Body bag for the illusion. And you can continue with the same experiment. Second experiment, Dr. Robotham affixed flags 5 feet high along the shoreline, one at every mile marker, then used his telescope mounted at 5 feet just behind the first flag. looked over the tops of all 6 flags, which lined up in a perfectly straight line. If the Earth were a ball, 25,000 miles in circumference, the flag should have progressively dipped down after the first establishing line of sight. The second would have descended 8 inches, 32 inches for the third, 6 feet for the fourth, 10 feet, 8 inches for the fifth, and 16 feet, 8 inches for the sixth. Again, I will defer to their mathematics, but there should definitely be measurable curvature. And again, there's none. Again, quoting number 64, quoting Earth is Not a Globe by Samuel Robotham. It is known that the horizon at sea, whatever distance it may extend to the right and left of the observer, we're just talking the observer, right? Observation, let's go. Always appears as a straight line. The following experiment has been tried in various parts of the country. At Brighton, on a rising ground near the race course, 2 poles were fixed in the earth 6 yards apart and directly opposite the sea. Between these poles, a line was tightly stretched parallel to the horizon. From the center of the line, the view embraced not less than 20 miles on each side, making a distance of 40 miles. A vessel was observed sailing directly westward, the line cutting the rigging a little above the bulwarks, which it did for several hours or until the vessel had sailed the whole distance of 40 miles. The ship coming into view from the east would have to ascend an inclined plane for 20 miles until it arrived at the center of the arc, whence it would have to descend for the same distance. The square of 20 miles multiplied by 8 inches gives 266 feet, as the amount the vessel would be below the line at the beginning and at the end of the 40 miles. I mean, look, I know we're getting sciencey, but you're going to have to dig on it. And he goes, deeper into this Dr. Robotham, you know what I mean? We're still just talking about the old Bedford level experiment. So, it just felt good to talk about this experimentation, get a little sciencey, talk about the double slit experiment and, put it in, just put it side by side with something that also deals with observation. You know what I'm saying? And this observation, what are you observing with water? What's repeatable? You know what I mean? Yeah, it's all possibilities. It's all possibilities. But what's the only observation you're ever gonna get when it comes to water? Curvature or level. If you're observing through their lens, they're gonna fix this curve in your mind, bro. You're gonna have to use, your dragonfly perspective and say, when has water ever curved into a ball? Ever. And you can dig on this link as well. Revelry.com, digging on the Bedford level experiment. If you're interested deeper in, you might want to recreate this experiment one day, man. Series of observations carried out along a 6-mile length of Old Bedford River on the Bedford level of the Cambridgeshire Fens in the United Kingdom during the 19th and 20th centuries to measure the curvature of the earth. Samuel Burley Robotham, who conducted the first observation starting in 1838. Oh no, this is some PSYOP drop. All right, so it's been a PSYOP of scientists trying to disprove this hijack even before 1838. Then you got the W.M. Christensen drop, 100 proofs the earth is not a globe, dropped on Johns Hopkins University's Facebook, still in the 1800s. And they've been doing this science, man. They've been doing repeatable and observable science using really common sense to prove you're not spinning on no round ball of water. All right. Water is always flat. Water never curves. Claimed that he had proven the earth to be flat. However, in 1870, after adjusting Robotham's method to avoid the effects of atmospheric refraction. See, this is what they then called it. That's why you got to see it and observe it on both sides. What the hijack did and said, oh, it's just atmospheric refraction. And then they start calling them mirages when they start seeing, cities and buildings that they shouldn't see from a distance. I think Chicago has this overlook where you can see, across this whole, bed of water across, to this other side. But when you measure the distance, there's no way you should be able to see these buildings from that far away. If you're on a ball, accounting, the curvature, no way you should be able to see that far. But then what do? They say, oh, it's just a refraction. It's just a mirage. All right, man. So that's the hijack. You can, definitely dig on, a lot more of the, step by step of this Bedford level popping off in 1838. Tell me if it's, crazy talk. You know what I mean? But at the end of the day, all they're saying is that there ain't no curvature. Water is always level, man. And it's what we've been witnessing, right? Let's go.
Hello. Thanks for having you again. Today we shall look at how water level proves flat Earth. The natural physics of water is to be level. Even a small child can prove the same. Water seeks its own level.
Do you think you're on a ball? Oh no, it's just, it's such, little curvature at a time. You won't be able to really perceive it. Look, man, the Most High gave you senses for a reason. You should be able to know if you're spinning at 1,100 miles per hour. 1,100 miles per hour is 1,100 miles per hour, no matter how big the ball is, okay? On a wobble, 67. You think you're going 67,000 miles per hour right now? Right now, my nigga? Right now? Come on, man. Sea level, not sea curve.
However, mainstream science wants you to ignore your experience and experimentation and instead believe that an invisible force, which cannot be replicated, detected, or proven in a lab, is responsible for...
We see water behaving like this. And never like this.
Bending oceans, lakes, and rivers, and has created uniform spherical bulges in water measuring thousands of miles deep. When I first heard about the flat Earth, I assumed that gravity was well proven in the lab since science says that.
That's crazy. It's sea level, not sea curve. Do you see clearly?
That gravity constitutes the driving force behind the formation of the universe. I was shocked to find out that gravity has never been proven and remains an unsubstantiated theory.
Bang.
Gravity is a farce that was created ex nihilo to only explain why we are not flung from a ball spinning at.
Now check this out. This is this Chinese bridge, right? 102.4 miles. Longest bridge in the world. Surely they accounted for the curvature of the Earth. I don't think so.
At 1,000 miles per hour. Have you ever seen gravity bend water? The surface of all water, when not agitated by natural causes, such as winds, tides, earthquakes, etc., is perfectly level. The sense of sight proves this to every unprejudiced and reasonable mind. Can any so-called scientist, who teaches that the Earth is a whirling globe, take a heap of liquid water, whirl it round, and so make rotundity? He cannot. Therefore it is utterly impossible to prove that an ocean is a whirling rotund section of a globular Earth, rushing through space at the line given rate of false philosophers. According to William Thomas Wiseman, the Earth is an irregular plane. Under the globe model, as a result of gravity, every body of water, even small basins, although too small to measure, must be curved and match the appropriate curvature drop of the Earth. Samuel Robotham wrote in Zetetic Astronomy. Earth not a globe, if the Earth is a globe, and is 25,000 English statute miles in circumference. The surface of all standing water must have a certain degree of convexity. Every part must be an arc of a circle. Beginning in 1838, Samuel Robotham began a series of experiments on the old Bedford River at the Bedford level in Norfolk, England at a distance of 6 miles. Essentially, Robetham marked a sign on a bridge and then traveled on a small boat down the river with a telescope affixed to the base of the boat at precisely 18 inches. He wrote, as the boat receded, the notice board was kept in view, and was plainly visible to the naked eye for several miles, but, through the telescope, it was distinctly seen throughout the whole distance of 6 miles. He then...
Just think about this model, man. Like, you're on a ball, man. You can't have flat land. You can't have flat water. But that goes against all conventional sense. And the Most High gave you sense. He gave you the sense of observation, right? So before you collapse the wave pattern into one possibility, surely you should know whose lens is it anyway? Whose lens are you looking through? Are you looking through this? Now, if water was even possible, if it was even possible, man, surely they would be doing experiments proving this spinning ball, right? I mean, surely we can duplicate a spinning ball of water. Nah. Oh, well, it's the universe. But then you got all these Earths out there, right? How many Earths they got? They got like, another billion Earths out there, right? Something like quadrillion Earths and all these other planets with water on them. Now look, man, water must be curving, right? The land is popping out the water, man. These are your beaches, right? You go from, here to, like I said, Hawaii, or here to somewhere else. Sure, you're going over this immense hump of water. But just think about it. Not everybody would be, if the boats were disappearing below the horizon, to some people, the horizon would be up. If you were down here on this part of the ball, you should be looking at a wall of water going up on the horizon. Not everybody got a horizon going down. Not on the ball, they don't. Not on the ball. On the ball, you got many perspectives. So where's the footage of anybody on any other part of the ball that must have another perspective other than some horizon going down and the boat going below the horizon? Maybe to these people, the boat would go below. Maybe to him, the boat would be going up over the horizon. And you see a wall of water just curving on up. Use your senses, my naga.
And even lowered the telescope to 8 inches and still the sign was visible. At an observational height of 8 inches, and the board being 6 miles away, there should have been a curvature drop of 16 feet 8 inches, that is, the sign should have been completely hidden below the curvature. However, there was no measurable curvature as the sign was clearly visible. Robetham repeated the experiment in 1844, 1849, 1856, 1862, and 1870. After the official fake test, all with the same result, no curvature. Of course, official science claimed that Robetham was wrong and the experiment was a failure, and so propagandists created a fake experiment with a maladjusted instrument in 1870 that resulted in failure.
And that's what they got when they said, oh, it must be atmospheric refraction. They just did a little quasi experiment to try to counter this because this was getting so much heat, right? So now they had to do a quasi experiment that resulted in failure. And oops, we disproved this. Let's go.
Don't have to take anyone's word for it. To prove Robetham, we ourselves conducted our own test at 6 miles across a body of water to replicate the findings of Robetham and recorded the whole thing. Unequivocally, there was no curvature on the body of water as required by official science. Ergo, the earth is flat. Some have countered by claiming that the flatness of the water is the result of refraction. However, refraction can only exist when the medium surrounding the observer is different to that in which the object is placed. Being surrounded with atmospheric air only, and the observer being in the same medium, there is no bending or refraction of the eye line. Robetham, Zetetica.
Remember what they just said, right? Hold up. I mean, we just read it in a separate source. How they tried to disprove this whole flow. What did they say? However, in 1870, so first, He claimed he had proven the earth is flat in 1838. However, 1870, it took him 32 years to figure out how to try to, throw a wrench in reality. After adjusting Robothon's method, they had to adjust his method to avoid the effects of atmospheric refraction. And this is what this cat is now saying. No, that's not even possible if they're in the same medium. Alfred Russel Wallace found a curvature consistent with the spherical Earth. Now you're on a ball. Let's get this again. I mean, we just are surfing the wave. All possibilities.
Of refraction. However, refraction can only exist when the medium surrounding the observer is different to that in which the object is placed. Being surrounded with atmospheric air only, and the observer being in the same medium, there is no bending or refraction of the eye line.
Atmospheric refraction is out of here.
Robitham, Zetetic astronomy. In most circumstances, refraction will not play a noticeable role as there is usually no measurable change in conditions, for example, temperature, air pressure, moisture, etc., between the two opposing points. Further, refraction, if it should have a noticeable impact, most certainly would not create the illusion that the Earth is flat but would instead produce a result similar to a Fata Morgana, which looks like a distorted mirror with upside-down images. Not a clear visible flat horizon as shown in the video above. Long rivers pose a problem under the globe model as the rivers eventually have to flow up the curvature. According to Eric Dubé's 200 proofs, Earth is not a spinning ball. Rivers run down to sea level, finding the easiest course, north, south, east, west, and all other intermediary directions over the Earth at the same time. If Earth were truly a spinning ball, then many of these rivers would be impossibly flowing uphill. For example, the Mississippi in its 3,000 miles would have to ascend 11 miles before reaching the Gulf of Mexico. One portion of the Nile River flows for 1,000 miles with a fall of only 1 foot. Parts of
Man. Yeah, man, you on a ball, man. I mean, this shit is impossible. Because these are just flowing, flowing with the wave. They're not going up no humps of water. They're not going, miles of curvature. No, they just flowing, man. They're just flowing on a plane of existence.
The West African Congo, according to the supposed inclination and movement of the ball Earth, would be sometimes running uphill and sometimes down. This would all...
And, research these balloon stratospheric tests. This is a very popular one. And, if they pan the camera up, you're going to see the small little sun, only 32 miles in diameter, like the Book of Enoch, breaks down just like the moon, forming a hot spot. So once you go up with your balloon, with your camera, you can see a literal hot spot from the sun. How in the hell can the sun make a hot spot direct like this from 96 million miles away? I'll wait. 96 million miles away. Is this a laser sun? Now, only if it's close, right? Only if it's only a few thousand miles. It's right here. It's right on top of us. It's not a laser sun. That light will be hitting us evenly from 96 million miles away. The whole thing would be illuminated evenly, not no spotlight.
Also be the case for the Parana, Paraguay, and other long rivers. Another proof of the flatness of water is the fact that under the sphere model, the bed of the ocean should be considerably less than the distance at the surface. Nevertheless, cables laid at the bottoms of the ocean, considering changes in terrain, etc., equal the distance at the surface. This shouldn't happen. The Earth is absolutely flat. Thanks for watching, everyone.
Body bag for the illusion. The Earth is flat in motion. This learning perspective is the most crucial part of realizing you live on a flat plane. We overstand that we're talking about a realm of existence, not just, The earth is from here to here. You're talking about a realm. The earth is a realm, not a spherical spinning realm, but a stationary, plane, a stationary realm. Again, the etymology of planet, you're just talking plane, to spread out, flat, spread out. That's just in the word. Just because they put a T at the end, right? They put their cross at the end, right? Just to, cross you up. You know what I mean? They just trying to do a crossover, man. They just talking about a flat plane. The horizon always remains at eye level. Water always seeks and finds its level. Research. Well, our last bit of research for the dismount is another great researcher. We're talking John G. Abazai. A book called The Enlightenment of the World in 1912. So we've been digging on recon, man, from the 1830s up to 1912. This ain't no recent, wave of knowing orientation. It's been hundreds and hundreds of years, hundreds and thousands of years of breaking down, orientation. You look at the cosmology of the Hebrews, right? You're just going to have a plane. You're going to have foundations. You're going to have firmament. None of that jives with a spinning ball. Where's the firmament? Where's the firmament on your spinning ball while you travel 67,000 miles per hour chasing the sun, right? Instead of being firm, fixed, and immovable and knowing that the sun is doing a circuit around you. Everything is doing, a dance like a chandelier around you. You got your fixed stars all within the firmament. We're just talking about the enlightenment of the world. Remember, we got this a while back, right? John G. Abazai. This book contains proof that the earth is flat and stationary, firm, fixed, and movable. Flat and stationary, while the sun, moon, and stars are in constant motion. Also, letters showing the testimony of Scripture on the subject. John Abazai wasn't on that play. He brought it back to the script. Firm, fixed, immovable. Firm, fixed, immovable. Over and over again, the script break it down. Over and over again, the script break it down. Let's just get it from right here. Chapter 1, right? You know that there is more water on the earth than dry land. Here's the first proof. The water proves that the earth is flat, level, and stationary. Water is liquid. It runs always down and seeks its level. That's what the vid we just got was breaking down with the Nile River and all that. It's seeking its level. It's running, north, south, east, west, based on the based on the basin, based on the foundation, So, if it's, going north or it's going south, it's based on finding its level. It's not just some imaginary flow. Water's always seeking its level. It runs always down and seeks its level and never runs up unless by power. But on a ball, surely water must be running up. But what about the gravity, though? And the water of the ocean is every way pretty near joined together on the earth, and they call it liquid. It will not stay on a round earth. It will not stay on a round earth. Take a glass of water and pour it on a round ball. And if the water stays on it, then the earth must be round. But if the water falls off, then the earth must be flat. You dig on it. This is the proof. Take a pan and fill it with water and see if it is higher in the center than on the sides. If it is true, then the water of the ocean must be round. But if the water of the pan is flat and level, then the water of the ocean must also be flat and level. Let's go. The water of the ocean is level and can be nothing else because it is liquid, which proves that the land is flat and not round. The land is not exactly flat and level, for there are mountains and valleys, But it makes no difference, for if the mountains were in the valleys, it would leave the land flat and level and higher than the water. I've been thinking of this equation for a long time. At last I found out for myself from the water and the sunbeams, the sun's rising, the sunlight, etc., that the earth cannot be round and in motion as books and teachers have taught. The teachers offer proofs to show that the earth is round, but the proofs they offer amount to nothing. When the children go to school and the teacher tells them the world is round, and of course they believe it, and they do not ask how it is round, they are young and they know very little. When they grow up, come on, let's get a little more. Hey, back it up. Whoa, back it up. Right there. All right. When they grow up, they still believe the earth is round and in motion. So you argue with grown-ass people who just still believe the same, inception that they were given. Remember the movie Inception? They plant that image, right? They still believe the earth is round and in motion. And so in turn, they teach this to others. The water is flat, which proves that the earth is flat and stationary. From its fruit, you will know what kind of tree it is, man. We're just talking about John Abazii. We're talking about being on a rim, that you're on a level rim. You are firm. You are fixed. You are immovable. Remember that great doc here, man? We always, if John Abazii take it to the script, we got to take it to the script with a dismount. 1 Chronicles 16:13, he has fixed the earth firm, immovable. No, you're spinning at 1,100 miles per hour, going 67,000 miles per hour in a vacuum of space on a wobble. But your senses don't pick that up. What kind of creation are you? What did the Creator create? If you don't have the senses to know if you're moving. He has fixed the earth firm, immovable. Thou hast fixed the earth immovable and firm. Psalms 93:1. Psalms 96:10. He has fixed the earth firm, immovable. Psalms 104. Thou didst fix the earth on its foundation so that it can never be shaken. No, you're spinning on a wobble. Isaiah 45:18. Who made the earth and fashioned it, and himself fixed it fast, man. Fashioned it, fixed, firm, immovable. Drop Nation, you are firm. Drop Nation, you are immovable. Drop Nation, you see clearly. All praise our Creator, our Most High, ancient head of days. This is a little science drop. You dig on it. We coming back, with some more strudels out the oven. Ahchwa.